the live stream cut off, so I'm trying to connect again. This is the second one. It just cut off in around, wait, let me see, 34, right? 1 hour and 34 minutes. It cut off around 1 and 34 minutes. It was just a second of delay from OBS. Okay, OBS was not connecting. There is so less of a bit rate, bro. When there is a lot of traffic in network, I can't stream. Wow. Okay, I'll say this again. It's not so bad nowadays. Okay, I'll say this again. I'll get to intermission. It's 4th January 2026 and we are at day 20, and this is second live stream, because the first one got briefly cut off because OBS was not connecting or something. It was more of a traffic. If this also gets like that, then I don't know what I will do, but I may as well leave that as it is. Let's see our we're talking about matrices, right? A non-singular, singular, and uniquely be expressed as sum of symmetric matrices, skew symmetric. Okay, and this was that a determinant. Yeah, we're at determinant now. Okay, the determinant of a matrix is a number associated with that square matrix. Uh, the determinant of a matrix can only be calculated for a square matrix. It is represented by modulus of A. The determinant of a matrix is calculated by adding the product of the elements of a matrix with their cofactors. So product with cofactors, that is, oh yeah, it has explained it here, but why is there E and F and H and J, bro? There is no E, F, J. So if A, B, C, D, E, F, I, J, K, A, B, C, D, E, F, I, J, K, why is there E, F, I, J? Never mind. If it's determinant, you just have to cut these two, multiply R with these V, W, Y, Z plus S, cut these row, these, multiply them like that, and cut these, and this. Okay. Determinant of 2 into 2 matrix is ADBC. Determinant. How to find determinant of 3 into 3 square matrix? It's nothing serious. You can just take any of the value in this row. Like, you can take the middle row D, and if it's D, then you have to multiply with BIHC, and if it's E, ACZI, F, ABDE. Okay, here A is taken, so A, EFHI multiplied, again this, these line are gone, DFGI. Okay, and there is also, if it's in middle, then minus. Okay, if it is in middle, then minus. It is just shown here that 1 plus 1 square, so this 1 will be nulled out. It will just be 1, because square of minus 1 is 1. Same for C, but not for B because uh, minus 1 cube is minus 1. Sorry. Minor of a matrix. The minor of a matrix for an element. A minor of a matrix for an element is given by the determinant of a matrix obtained after deleting the row and column to which the particular element belongs. Minor of a matrix is represented by Mij. Let's see an example. Find the minor of matrix A, B, C, D, E, F, G, H, I for the element I. A. So minor of a matrix is E, F, H, I. E, F, H, I because A got these rows and columns, rows and columns. Okay, cofactor of a matrix. Cofactor of a matrix is found by multiplying the minor of a matrix for a given element by minus 1 ij. Cofactor of a matrix is represented as Cij. Hence, the relation between the minor and the cofactor of matrix is given as Cij is equals to minus 1 ij mij. If we arrange all cofactors obtained from our element T, then we get a cofactor matrix given as this. Adjoint of our matrix. Okay, minus 1 I plus j mij. Okay, that is the cofactor. Adjoint of matrix. The adjoint is calculated for a square matrix. The adjoint of a matrix is transpose of the cofactor of the matrix. The adjoint of matrix is thus represented as ADJ CT, where C is the cofactor matrix. Interchange this, change signs for 2 into 2. Interchange these, change signs. Let's say, for example, we have 3 comma 3 matrix, then we can just transpose. Okay, transpose is a cofactor of a matrix. So if we transpose, this is cofactor matrix, what it's doing. Okay, inverse of a matrix. For a square matrix of order n, its inverse A inverse can be defined as a matrix which, when multiplied by the original matrix inverse identity matrix of order n, that is, this inverse is only calculated for square matrices whose determinant is non-zero. Formula of inverse is given as this. Okay, A minus 1 is adjoint by determinant of that matrix should not be equal to 0, which means matrix A should be non-singular. Elementary operations of matrix: interchanging two rows. Elementary operations include linear k multiplying row and column with non-zero numbers, adding two rows and columns. Rank of a matrix. Rank of a matrix is given by the maximum number of linearly independent rows or columns of a matrix. The rank of a matrix is always less than or equal to the total number of rows or columns present in a matrix. A square matrix has linearly independent rows or columns if the matrix is not non-singular, that is, determinant is not equal to 0. Since a 0 matrix has no linearly independent rows or columns, its rank is 0. The rank of a matrix A is represented by tau or E sigma. Tau is like this, right? It's called density. I looked it up before too, but I don't know why I'm not forgetting. Matrices formula, and these are all the formulas that need to be remembered, which I remember and don't want to see. Why matrices matter in data science? Okay, then why does a matrix matter in data science? Efficient data representations. Tabular data like datasets in CSV files or spreadsheets can be easily stored as matrices. Foundation for ML models. Algorithms like linear regression, neural networks, and PCA use matrix. Operations vectorized computation libraries like NumPy, TensorFlow, and PyTorch use matrix operation to speed up calculations using hardware acceleration. Dataset with multiple features for observation are naturally represented as matrices. Common uses matrix in data science. Stored dataset, each row is an observation, a customer, and each column is feature. For example, linear algebra in machine learning matrices are used for matrix multiplication, linear regression, gradient calculation in optimization, transformation and projection in dimensionality reduction, PCA, image processing. Images are represented as matrices, grayscales or tensors, color images with RGB channels where each pixel is a value in the matrix. Natural language processing (NLP) matrices represent word embeddings or sentence vectors. For example, a word-to-vec model converts words into dense vectors and arranges them into a matrix. Recommender systems, user item matrix stores preferences which can be used for collaborative filtering using matrix factorization. And these are some problems. Introduction to matrices. Don't need to do this. Mark. Feature selection using chi-square. Mm, I want to do it separately. Like, what should we do? Should we first read and then do the code, or after and then first do the code and then after? What is the input? Okay. Mm, 30 minutes left, right? I'll sit around 1 hour here. Well, that will be too far. I have to cook meal too. I have to cook meal myself today, which is following describes the role posterior belief distribution in Bayesian statistics. Represents initial assumption before observing data, prior data occurring under the hypothesis, prior belief after incorporating new data. Yes. What is the main difference between Bayesian and frequentist statistics? Bayesian statistics assumes probabilities are fixed, while frequentistic statistics observe probabilities with data. Statistics relies on prior beliefs, while on these observed data. Updates probabilities using prior knowledge and new data, while because it assumes fixed probabilities based on repeated trials. And the uncertainty better than. Okay. In context of Bayesian inference, what is the purpose of likelihood function? To define the prior probability distribution, to normalize the posterior distribution, to represent the final updated belief after observing new data, to determine the probability of the observed data given a hypothesis. Likelihood function is uh, opposite of posterior, right? To determine the probability of the observed data given a hypothesis. Mm, I guess I'm gonna make wrong here. To define the prior probability distribution. This is not it. Mm, to normalize posterior distribution. Don't know. Yeah, it was this. Shh. Knew it, I would make it wrong because I was already confused. Matrix with 3 rows and 4 columns, 3 into 4, which one has all elements 0. What is the primary purpose of using chi-square testing feature selection? with numerical to determine the reason category features. To transform category data into numerical features. Okay, this one we haven't done, but should be able to. Okay, these are for all the chi-square and FN test, right? These are will be doing. Okay, let's read first. Uh, do the quiz. I'll go and I'll do the code. Show it to you tomorrow. Do the code. What I'm just copy and pasting, right? So no need. I have written here. One is chain, one is chi-square, and third is manual. Okay, and I have to explain what the code does tomorrow for you. Fine. I'm not be sitting here. Okay, I have to make food too for me to eat. Then let's see feature selection using chi-square test. Feature selection is an important step in building machine learning models. It helps improve model performance by selecting only the most relevant features, reduce noise and computational cost. One common method for feature selection in classification problem is a chi-square test. Okay, features are important in building machine learning models. It helps improve model performance by selecting only the most relevant features. That is, that predicts the actual feature want, reduce noise, computational cost. Chi-square test measures the relationship between categorical independent variables and a categorical target variable. Okay, it finds measures the relationship. It helps us to find if an independent variable is related to the target variable or not. We use it when the target variable is categorical, like yes, no, pass, fail, spam, not spam. The independent variables are also categorical, like gender, education level, purchase category. Okay, everything categorical. Steps for feature selection using chi-square test. Prepare the data. Ensure that both the independent variable and target variable are categorical. Convert categories to numbers. Use encoding techniques like label encoding or one-hot encoding to encode the categories as numbers. Compute chi-square scores. Calculate the chi-square statistics for each feature relative to the target variable, and select top features. Choose features with the highest chi-square values as they have the strongest relationship with the target variable. For better understanding, refer to chi-square test in machine learning, which was what we learned previous classes. Real world example, customer purchase prediction. We will use a real world dataset from predict a customer purchase behavior dataset. This dataset contains demographic information, purchasing habits, and other important features to predict customer purchase behavior. Loading and preparing the dataset will be using pandas library for loading the dataset into pandas data frame, and skylearn library to do feature selection. You can download the dataset from here. We have already downloaded that, and import pandas as pd, import skylearn, and pd.read csv will give the file that we downloaded csv file, and will print the data frame head. Okay, so we'll print this. Output will be these. These are the heads, means five labels. No, it's not called labels, but it's called, okay, never mind. It's five values, and every features. Okay, these are features that are columns, and it will only give five. This helps us get us initial idea of the data and understand the structure of the data set too. So it helps us find get us idea about the data set. Okay, data summary. So we summarize the data set to understand its properties. So df.info will give everything, like if there's null, count, and type of the data that we get, and here describe will give the count, means, std, like that. And these are 25 percentile, 50% and 75%, and maximum. We can look at if there is any outliers or not. This will do that. It will provide summaries. provides an overview of data, missing values, and statistical distribution. Data cleaning. Cleaning the data ensures that it is suitable for analysis. We check and remove missing values. This ensures our data set is complete and ready for processing. So df is null dot sum is in data frame is null, and dot sum will print the values not printed. Then df dot is sol is num is equals to here, nothing done. So drop the any method will drop any non is null value. So that is the case. Feature encoding. So from here, wait, I'll come back. Okay, I'll come back from this room. Okay, I'm back, and uh, it's feature encoding. Okay, we're looking at data cleaning where the null uh, values were dropped, means that whole line row was dropped. Okay, you can say row. Hmm, I forgot about that. Leave it. Okay. Since the chi-square test requires numerical input, so we convert categorical value variables into numbers using label encoding. Okay, so using label encoding, we'll convert categorical variables into numbers as chi-square test requires numerical input. This step ensures that categorical variables can be used in statistical tests and machine learning models. So from sklearning pre-processing, importing a label encoder, and LE is equals to label encoder is called, and categorical features, gender, age, annual income, product category, which are these that are for feature in categorical feature. For feature means single gender, gender coming here, df gender, which will give data frame, which will go to that data frame gender, and le dot feed transform df feature, then it will transform it into a new number, and it will be for the others too. Then df purchase will feed the transform purchase status, and df purchase status. So purchase status is there. Purchase status is there. Okay, purchase status there. It will give. It will write in purchase and applying chi-square test. Now we will apply chi-square test to determine which features are most relevant to target variable. This step helps identify the features with the strongest relationship to customer purchases. So import chi-square to select k-based feature selection, category features, purchase, and select k-based function chi2 and k2 selected feed transform, so it will give x big X and y into x new feature score, selected score, x column, selected get support, features feature scores and selected features. So feature scores are 5 into 10 to the power minus 3, 8 into 10 to the power 2, 1 into 10 to the power 4, and 8 into 10 to the power minus 2. Intent minus 2. Selected features index is an annual income D type object. Okay. This test assigns highest score to features that are strongly related to target variable. Based on these scores, we select the top features that contribute most to predicting purchases, like the results shown. Why categorical features are these four? Like the results shown in the following scores, gender is 0.0051, age is 8.899.99, annual income is 12,219.66 per product category is this. From these scores, age and annual income have the highest chi-square values, meaning that they are the most relevant feature for predicting customer purchase behavior. Okay, these features will be selected for model, while gender and product category will be excluded as they have the weak statistical relationship with target variable. And I'll be doing this. I'll be just copying it and pasting, and based on these given to me, I'll do it. Market read, and let's go to FANOVA using FANOVA. Okay, feature selection using FANOVA. Is there any? Oh no, nothing. FANOVA, F statistic based analysis of variance, is a statistical method that finds how well a feature distinguishes between different classes by comparing variability between classes to variability within each class. Okay. uh, a higher f statistic shows that the feature is effective in class separation, while a lower value suggests it is less useful. F statistic formula is defined as f is equals to variance between groups and variance within groups, where variance between groups average of squared differences between each class's mean and overall mean. Okay, and variance within groups average of different squared differences between data points in each class and their respective class mean. Step to calculate the F statistic. Calculate the mean of each class. Calculate the overall mean of target variable. Compute the variance between classes. Compute the variance within each class. Calculate the F statistic by taking the ratio of between group and within group. Okay. How FANOVA is used for feature selection. FANOVA helps in selecting the most important features for classification problem. For classification problem, it is for categorical problem, and the steps involved in feature selection using it are as follows: calculate F statistic for each feature. For each feature in data set, find the F statistic with respect to the target variable. This will give a measure of how well the feature differentiates between the classes. Rank the features, sort the features based on their F statistic with higher values, shows more discriminative feature. Select top features. Choose the top features with the highest F statistics, which are considered the most important for the target variable. Model training. Once the top features are selected, they can be used to train machine learning models like logistic regression, decision trees, support vector machines, SVM. We looked at into it, decision machine. We were familiar. Uh, we were basically some basic familiaristic with logistic regression and this all. This reduces the dimensionality of the dataset and improves model performance. Implementation of F ANOVA for feature selection. In this example, we use the F classic function from sklearn feature selection to find F statistic for each feature and select the top features based on the highest F score. Okay. Loading iris dataset from sklearn datasets. We will be using pandas and skylearn libraries for its implementation. So train test split. We are splitting the train test x by test size 0.3. Random state 42 lists the dataset X features and Y targets into training and testing sets with 30% of data allocated to testing and a random seed cell for reproducibility. Okay, correct. Oh, I'll be doing this F ANOVA too in my own laptop if I can. Pandas as PD, sklearn datasets input, load iris, sklearn feature selection input, select k based, F classic if, input train test split, ensemble random forest classifier, metric input, accuracy score, data load iris, and PD data frame, column data dot features name, PD series. It will create a series. By feature selection, select k-base, current feature scoring function app class which finds the statistics. Here we top two features k2, but we can modify k to select for more or fewer features. So we are selecting only two features that are petal length and petal width. So these are the two features that the app scores F ANOVA found. For F ANOVA selected model training and evaluation, we train a random forest classifier using only the selected features. So random forest classifier, random state 42, model fit, X train selected, Y train, and predict model predict X test selected, accuracy score I predicted. So accuracy model with selected features. Also experimented with other classifiers like SVM, logistic regression, etc. So it is using random forest classifier. Okay. Limitations of FNUVA. While FNUVA is a useful tool for feature selection, it has some limitations. Assume normality. It assumes that the data within each class is normally distributed. If the data is not normally distributed, the F statistic might not be reliable. Only for classification. It is generally used for classification problems and may not be suitable for regression tasks. Uh, Ignores feature interactions. It evaluates each feature independently and may not capture the complex interactions between features that contribute to the target variable. Sensitive to outliers. Like other statistical methods, it can be sensitive to outliers, which may distort the variance calculation. Multicollinearity. It may not perform well in the presence of high correlated features. Okay. What is the primary purpose of using chi-square test in feature selection? What is the primary purpose of chi-square test? To measure the relationship between numerical variables, to determine relationship between categorical features and target variable, to transform category data into numerical data to reduce dimensionality. This is the answer, right? Yep, right. Which of the following is a necessary step before applying chi-square test? Convert categorical variable into numerical, remove all numerical features from the data set, apply PCA to the data set, normalize all numerical features. If a feature has a very low chi-square score, what does it indicate? The feature has a strong relationship with target, little or no influence on the target, the feature is continuous, should be removed, needs more data for basic results. Okay. What does a high F statistic value indicate in FNOVA feature selection? The feature has deeper course overview and we'll start with basic of NumPy. OBS was just gone and I don't think I have a good stream now. Is the stream up? Is my answer. Is the stream up? Let me see. Uh, is the stream actually up? Yep, it shows live. It shows live. Don't know if it's live. It's showing me live, then it should be. Okay. Uh, okay, it's showing me live, and I was doing the thing. OBS is. I don't want to say shit, but it's good. But it's always disconnecting. Why I don't know. It's because of the network fluctuation, I guess. My network fluctuation is too bad. And oh yeah, basics of NumPy break day. We'll be doing Python and pandas for break day too. Why do we take a break day? There is no need to take a break day as we are already at here's day 20 and we're already 1 week behind according to here, but we were not starting from day one in this code, no. So no rush in that. Let's see my score 730. We need 2160 for cutoff. It will it will do it, and 275 complete, 22% complete, 1280 left. So I don't think it's accurate, but 22 is enough. There are a lot of weight, and okay, let's look at the course overview. Right. Course plan. Welcome to week 3 of your data science course. This week is focused on exploratory data analysis (EDA). We'll learn how to explore, clean, and understand data using Python libraries like Pandas, NumPy. These skills are essential before building any machine learning model. By the end of this week, you'll be able to handle real-world data sets and extract useful insights from them. Hope I do. Let me see. NumPy. Arrays store and process numerical data. Wait. Where are you going? Stop here. Yeah. Indexing and ND arrays access elements using positions. Array math perform arithmetic operations, apply operations across sets automatically. Broadcasting. Pandas library used for data analysis in Python, data frame, tables like data structure, loading data, read, CSV, Excel, and more. Basic operation: view, filter, and sort data. Explore data, check shape and info, mean, median, modes, summary stats, column D types, read CSV, Excel, and more. Preview first and last row, that is head and tail, and null values, detect and fill, drop missing data that we did drop any, duplicates, find and remove repeat rows, clean data, prepare data for data analysis, group by analyze within data, important aggregation, calculate sum average count by group, this is also important, outliers, support and handle extreme values, this is also needed. Correlation matrix, we have to understand this, measures relationship between columns, links among variables, help find, use feature selection for modeling. Yeah, done. Okay, what we'll be doing: day 15 NumPy basics, get introduced to NumPy used for handling numerical data, create arrays using ND array, learn indexing, slicing, and arithmetic operations, understand broadcasting in NumPy, and break day. Test your knowledge with a full recap, MCQs covering all 15 days. Use this day to revise and strengthen your understanding. Uh, what do we do? We'll take this as a break day or what? Well, that depends on the mood. Tomorrow we'll be doing this anyway. So, if tomorrow is sort of faster, then we'll give break the slap right there and start day after tomorrow with 16 Python pandas for data analysis. Start learning pandas, a useful tool to work with structured data, read, review, and understand dataset using pandas, learn about data frames, series, perform basic operation like filtering and sorting, data set exploration with pandas, dig deeper into data sets and understand their structure, check columns, names, data types, and shapes of dataset, use functions like info, describe, head to explore data, handle null and duplicates values, group by outliers, correlation matrix, create and read correlation matrix, practice problems on pandas and numpy, solve 20 beginner level pandas and oh, okay, there are questions. Let me see. Oh yeah, practice problems. There are 10 problems. Okay. There are 10 problems, right? There are only 10 problems. It was 2020, man. You said 2020. Where's 2020? 2020. No 20. It's 10. Okay. Nevertheless, and this will be good. And okay. If I want to type or not. This has been running. Sorry about that. I have to look at it. Sorry, Sartak, brother. Dada. Sartak, brother. Let's see. Okay. I guess we'll end this here. It's already time and I have to make Don't complete that. Okay, this is it for today. I'll see you tomorrow. Mm, we'll learn NumPy. And that's it for today's session. It's cut into half, but it's working. No worries. Okay, bye.